Hi dear students, how are you? Welcome to our channel Mrchemistry, and today we are going to discuss most important questions from surface chemistry, and here already first question is there. Let us see first one. In reference to Friendlich adsorption isotherm, write the expression for adsorption of gases on solids in the form of an equation. See here, according to Friendlich adsorption isotherm, the expression for gases adsorbed on the surface of solids means adsorbent x by m is equal to k p to the power of n. Here n value should be greater than 1. Okay, and see here, if you write the same thing in terms of logarithms, log x by m is equal to log k plus 1 by n log p. Okay, and see here x is nothing but mass of the gas adsorbed on the surface of the adsorbent per gram. Okay, here m is mass of the adsorbent, and see here k and n, these two are constants. These two are constants, depend on nature of the adsorbent and nature of the gas at particular temperature. And here P is equal to pressure. Okay, pressure of the gas on the surface of the adsorbent. Here x by m is nothing but the mass of the gas, adsorbed per gram of the adsorbent Okay, please note down this one and we will move to next one. Second question is, write one difference of the following. They give a solution and colloid. They are asking the differences between solution and colloid. See here, if you consider solution and colloid, see here there is a difference in the size of the particles. Okay, see here the size of the particles, the size of the solution particles are less than 1 nanometer, Here in case of colloids, the size of the particles are in the range of 1 nanometer to 1000 nanometer. Okay, see here these are very microscopic particles in case of solution, whereas colloidal particles, the size of the particles are little bit bigger than solutions. Okay, and see here solution does not shows Tyndall effect. In case of colloid, it shows Tyndall effect. And one more difference, it does not shows Brownian movement. The particles of solution are not showing Brownian movement, whereas the particles of colloid solution, particles of colloid solution, it shows Brownian movement. We are using the term colloidal solution, but actually it is not true solution. Okay, solutions are true solutions These are not true solutions because there is a difference in the size of the particles. Okay, don't get confusion. And here it shows the particles of colloid shows Brownian movement. It shows Brownian movement. Okay, please note down the differences. They are asking one difference, but learn two more. Nothing wrong in it. Okay, please note down this one. Third one is in reference to surface chemistry, define dialysis. Okay, and in your biology you already learned dialysis. It is a process. Okay, it is a process especially used in case of patients who are suffering from failure of kidneys. Okay, and see here now in reference to surface chemistry we are going to define dialysis. Okay, dialysis is nothing but it is a process. What process it is? It is a process of removing. It is a process of removing dissolved substance. Okay, dissolved substance from a colloid by means of diffusion. Through a suitable membrane. It is a process of removing dissolved substance from a colloid by means of diffusion through a suitable membrane. Okay, and in case of dialysis patients, the dissolved salts present in the blood are removed through a process called dialysis. Okay, please note down this one and we will move to next one. Okay, check the fourth one. They are asking one example each of sol and gel. Sol and gel are two different types of colloids. Okay, let us see in detail. Type of colloid, and we will write here first one as a sol and the second one as a gel. Okay, sol and gel. And next one, what is the dispersed phase? And what is a dispersion medium? And they are asking examples now. We will write examples here. Examples. And see here the dispersed phase. In case of sol. See here the dispersed phase is a solid dispersed in liquid. The dispersed phase in sol is a solid and dispersion medium is liquid. And examples for these things: paints and cell fluids, means fluids of the cell. And next one is gel. In case of gel, the dispersed phase is liquid. Just reverse. Liquid and liquid dispersed in solid. Example for these gels are, jelly chocolates, jellies. You can take cheese, butter are also examples comes under gels. Okay, please note down this one. Type of colloid is a sol, dispersed phase is solid and dispersion medium is liquid. Example for sols are paints and cell fluids. And next colloid is a gel, and here dispersed phase is liquid and liquid dispersed in dispersion medium, that is solid. Okay, examples for gels, jellies, cheese, butter. Okay, next we will move to fifth one. Please note down this one. See here, fifth one is what causes Brownian movement in a colloidal solution. Brownian movement in the sense it is a zigzag movement in the colloidal solution. Okay, and see here they are asking what causes, means what is the reason for Brownian movement in colloidal solution. See here, in the colloidal solution, dispersion medium, it is like a solvent in true solutions, means present in more quantity. Okay, dispersion medium particles. Okay, particles of dispersion medium, continuously hits the colloidal particles, means dispersed phase. See here, due to the continuous hitting of dispersion medium particles with colloidal particles, it causes Brownian movement. Okay, particles of dispersion medium continuously hits the colloidal particles, which causes the Brownian movement. Okay, and see here, if you consider there is dispersion medium, and in the dispersion medium dispersed particles will be there, dispersed phase. Okay, see here, due to continuous hitting of the particles, dispersed phase and dispersed particles, dispersed phase particles and dispersion medium particles. Okay, what will happen? They will move in a zigzag pattern inside the colloidal solution. Okay, once again check it. Particles of dispersion medium continuously hits the colloidal particles, which causes Brownian movement. Okay, please note down, and we will move to sixth one. Sixth one is define the following terms. They given two terms, Tyndall effect and electrophoresis, these two related to colloidal solutions. And see here, Tyndall effect, it is nothing but the scattering of light by colloidal particles, Tyndall effect is nothing but the scattering of light by colloidal particles is called Tyndall effect. And comes to electrophoresis, it is nothing but the movement of colloidal particles, colloidal particles towards an applied electric potential. The movement of colloidal particles towards an applied electric potential is called electrophoresis, and the process of, or you can say the process, or no problem, the scattering of light by colloidal particles is called Tyndall effect. These two are characteristic features of colloidal solution. Okay, please note down. Seventh one is, what happens when freshly prepared ferric hydroxide is shaken with a little amount of dilute solution of ferric chloride? Okay, they are asking what happens. What happens when freshly prepared ferric hydroxide is shaken with a little amount of dilute solution of ferric chloride? What will happen? We will see. See here, freshly prepared FeOH tries means ferric hydroxide. It is a precipitate. It is a precipitate. Okay. When it is shaken with a little amount of dilute solution of ferric chloride, what are the ions present in ferric chloride? Fe+3 and Cl-. Fe+3 and Cl- are present in that one. See here, after shaking, what will happen? This one will join with this one. As a result, it forms FeOH tries Fe plus 3 chloride ions. And here it is nothing but positively charged colloidal solution. And this process of converting precipitate to colloidal solution is called peptidation. Okay, please note down this one, peptidation. And the charge of that one is positive charge. Please note down this one. And next one is, what happens when persistent dialysis of colloidal solution is carried out? Okay. See here, continuous dialysis forms a precipitate. Okay, continuous dialysis forms precipitate. Okay, when what happens when persistent dialysis of colloidal solution is carried out? In the sense, if you continuously doing that dialysis, what will happen? Finally, it forms precipitate. Okay, and you make a note here. Removal of complete ions from the colloidal solution, from the colloidal solution leads to instability of solution. Colloidal solution. Please note down this one. Under 8th one, they are asking, write one difference between the following terms. They given multimolecular and associated colloids, and under B they given salts and gels. We already discussed the salts and gels. You refer previous one and check the first one, multimolecular and associated colloids. Multimolecular. See here, multimolecular colloids are nothing but the colloids formed, see here, on dissolution, a large number of atoms, or you can say small size molecule. Okay, small size molecules aggregate together and they form multimolecular colloids. Okay, please check this one. On dissolution, a large number of atoms or small size molecules aggregate together to form multimolecular colloids. multimolecular colloids. And check this one, next one, associated colloids. Associated colloids. See here, some substances at lower concentration acts as good, or you can say strong electrolytes. Okay, and see here, some substances at lower concentration acts as strong electrolytes. See here, but at higher concentration they forms associated colloids, means it behaves like a colloidal solution. Okay, the same substance at a higher concentration, it shows colloidal behavior. At a higher concentration it forms associated colloids. Please note down this one. And salts and gels we already discussed. Salt is solid in liquid type, example paints and fluids of cell, and in case of gel it is liquid present in the solid, example gel is cheese, butter. Okay, please note down this one and we will discuss next one. Ninth one is, what is an adsorption isotherm? And they are asking one more question in it. Describe Friendlich adsorption isotherm. First we will see adsorption isotherm. See here, adsorption isotherm. See here, adsorption isotherm is nothing but the variation in the amount of gas adsorbed, okay, the variation in the amount of gas adsorbed by the adsorbent with pressure at constant temperature. Temperature is constant here. The variation in the amount of gas adsorbed by the adsorbent with pressure, with respect to pressure at constant temperature is called adsorption isotherm. Okay, please note down this one. And next one is describe Friendlich adsorption isotherm. See here, in the first question itself we already discussed Friendlich adsorption isotherm. X, what is the relation here? X by m means the amount of gas adsorbed by the adsorbent per gram. Okay, X by m is equal to Kp to the power of n, and condition is here n should be greater than 1. This is the relation. See here, if you consider Friendlich adsorption isotherm, see here, it is like this. Pressure, amount of gas adsorbed by adsorbent per gram. Okay, see here, at 273 Kelvin, at 244 Kelvin, at 195 Kelvin, see here, observe the variation in the amount of gas adsorbed per gram of the adsorbent at different pressures and at constant temperature. If you consider constant temperature 273, it will be like this, and at 244 Kelvin and 195 Kelvin. Okay, please note down this one. This is the relation between amount of gas adsorbed per gram of the adsorbent, and see here the relation is that is equal to Kp to the power of n, and condition is n is greater than 1. Here n and k are constant, n and k are constants. Okay, please note down, this is Freundlich adsorption isotherm, Freundlich adsorption isotherm. Please note down. And last one is 10th one, give reason for the following. Brownian movement provides stability to the colloidal solution. They are asking reason. And a true solution does not show Tyndall effect. And third one is C, addition of alum purifies water. Okay, let us check one by one. First one is Brownian movement provides stability to the colloidal solution. See here, because of the Brownian movement, what is Brownian movement? The movement of the colloidal particles due to hitting of each other. Okay, see here, because of that zigzag movement, I mean Brownian movement of these particles, colloidal particles does not settle down. Because of that one, the stability will continue in case of colloidal solution. It does not allow colloidal particles to settle down because of Brownian movement. And second one is a true solution does not show Tyndall effect. What is Tyndall effect? Scattering of light by the colloidal particles. In case of true solution, the size of the particles is very small compared to colloidal particles. Because of very small size of the particles of the true solution, it does not show Tyndall effect. Okay, Tyndall effect is scattering of light by the colloidal particles. And third one, C, is addition of alum purifies water. What is alum here? Potassium aluminum sulfates is called alum. Okay, Al2SO4 trice, aluminum sulfate. See here, these aluminum sulfates, they give aluminum hydroxide. Okay, it is a gel-like substance. Aluminum hydroxide is gel-like substance. This gel-like substance attracts and settle down the impurities. Okay, this gel-like aluminum hydroxide attracts and settle down the impurities. Okay, because of settling down of the impurities by aluminum hydroxide formed due to alum present in the water, it helps in the purification of water. Okay, and see here, check all these things and revise all the questions, and in next class we will continue with one more good lesson with respect to CBSE board exams. Okay, and until then, but don't forget to subscribe our channel Mrchemistry. Okay, please like it, share it. Thank you all of you.